Hey guys, how are y'all today? I hope y'all are doing really awesome. I still want you to know if you need anything at all, please feel free to inbox me. I'm pretty quick about responding, so I just want to make sure that you know that I'm here for you. I miss you so much, and I'm like so ready to work with y'all. And I know this is a crazy world right now, but I love y'all. Okay, enough sappiness. Let's get on with the lesson. So, today we're working with proportions with percents. The past couple weeks, we've been working with just normal proportions where you're given two units like hours and miles. You set up the information given, and then you are solving for something that you don't know. These problems are similar, so you're still solving for something you don't know, but in this case, there's a percentage involved. When you're working with a percentage, your units are always going to be part and total. Even though in some problems, like let's look at our first example, it's talking about questions correct. Your units aren't going to be questions and questions or questions and correct or anything like that. It's going to actually be part and total. Because when you're working with percentages, it's always going to be a part of a percentage out of a total percentage, which is 100. So I'm going to go ahead and work through this one. I'm actually going to work through the first two. So you have Caitlin got 30 questions correct out of a total of 35. So we already know some information there. She got 30 questions correct. Total number of questions is 35. What was the percentage she got correct? So the thing that we're missing is the actual percentage. So we're going to put X here. We don't know the percent. We know if she got all of them right, she would have got a 100%. That would be our total percentage. Our part and total out of our questions would be 30 out of 35. So again, just like before, we cross multiply the ones that are diagonal from each other. Actually, if you're looking at the problem, it looks like that. These two are diagonal from each other, so 30 times 100 would be 3,000. And then you divide it by that extra number, which is 35. Okay, and when I solved that, I got 85.71%. So if I was going to round that to a whole number, ooh, that didn't look good. If I was going to round that to a whole number, I would get 86%. That was her grade that she got on her test, 86%. All right, let's go ahead and look at number 2. So again, I'm going to set up my ratio table with part and total. Ayana's car had used 30 gallons of fuel from a 50-gallon tank. What percentage was used? So we have 30 out of 50. That's what we're given. The other number that's always going to be there in a percentage proportion is 100%. That's the other number that basically you are given. Because it's a percentage problem, we know that's the total percent. Oh, my lights turned out. So we want to know what percentage was used. So again, we're going to cross multiply 30 times 100, which we already know is 3,000. Divide that by 50. And when I just solve that in my calculator, I get 60. And in my problem, what that represents is she used 60% of her gasoline in her tank. I'm going to do another problem where they actually give you the percent. Let me find one. Okay, here's a good one. Number 3. Kathy's Boutique is selling bracelets at 40% off. If a bracelet is normally $22, how much money will be taken off of the total? So I'm going to set up my part and my total. I'm solving for 40% off out of 100%. The bracelet is normally $22. So you have to think in your mind, $22. Is that the part of the bracelet that we're taking off, or is that the total amount of the bracelet? It would be the total. So 22 is the total amount of the bracelet. I'm going to cross multiply here. 22 times 40, which is 880, divided by our extra number, which is 100, and it comes out to 8.8. Now, if I'm thinking back to the problem, my answer might not be 8.8. We really need to read the problem and figure out how does that number relate back to the problem. A lot of times when people are getting math questions wrong, it's because they just solve a problem and get an answer and think, okay, there's my answer. But we need to make sure that's really what they're asking. If a bracelet is normally $22, how much money is taken off of the total? So we are just solving for that number that's taken off, right? We're not asked to solve how much is the bracelet now. We're asking how much is taken off, which is 8.8. Now, if I was going to answer what they're asking is money, that would turn into, and I'm going to write it in green just because that's money, $8.80. That is actually what they're asking, how much money is taken off. So you always want to do that, especially in these percent proportions, because they could be asking, like on this one, instead of solving for how much is taken off, they could ask how much now do you have to pay. So you would actually do 22 minus 880. That's a huge part of these math problems, is really reading, understanding what the question is asking. All right, guys, so if you have any questions, message me in the inbox. Again, I love y'all. I miss y'all. I'm ready to see your sweet faces, even if they're behind a mask. I know that it's a hard transition, but I love y'all, and I hope y'all are having an amazing day. Bye.